So in this video, we start off with an important fact here. The fact is that if you understand the meaning of the row space and the column space of a matrix M already, surprisingly, the fact is that the dimension of the two spaces is the same, no matter which matrix is given to you, although the exact space for the row space and the column space may be different, but I'm claiming the important fact is the dimension must be the same. And let's look at this example. If you look at the current matrix M, which is already in a reduced form, there's no operation we can carry out. And you can look at the row space now. What is the dimension of the row space? I think the dimension is 2, right? Because of the fact that we can use the bases to be formed by the row 1 and the row 2, I think. And let's look at the column space now. And for the column space, you see, we can look at the non-zero spot. If it is already in the upper triangular form like this, you see, we can basically use the first vector and the fourth vector to be the basis of the column space, right? It's column 1 and column 4. So once again, the dimension is 2. So it's a simple example, but just to give you a sense that the dimension is actually the same, no matter which matrix is given to you. And if you try to describe the row space more precisely, you see both rows have actually 4 coordinates, right? So it means both rows are actually in R4. So it basically means the row space is a 2-dimensional subspace in R4, right? And how about the column space? The column space, you see, each column vector actually has 3 coordinates. It means the column space actually must be sitting in R3. And we understand that the dimension is 2. It basically means it's a 2-dimensional subspace sitting in R3. And of course, these two spaces, they are not the same, right? But what I'm emphasizing is the dimension is actually the same. And because of this fact, we can actually make a new definition based on the matrix M. So the rank of a matrix M is basically the dimension of the row space of the matrix M, or you can call it the dimension of the column space of matrix M. And let's do one example to find the rank of M. So please look at the current matrix now. I would like you to tell me the rank of M, and we can do some reductions as usual. So we can do row 2 minus 2 times row 1. We can also do row 3 minus 3 times 1. Then you are arriving at an updated matrix. You see that's the matrix you have. I think this spot can be reduced further. So we can use something like row 3 plus row 2 to update the last row. So I'm sorry, it should be row 3 minus row 2. And you're getting the last row to be something like that. And now you see it's kind of like an upper triangular matrix. And we can look at the non-zero spot. It gives you a sense that the dimension of the column space and the row space must be the same as 3. And it means the rank of the matrix M is actually 3, right? And that's the end of this video.